Okay, I'm delighted to introduce our next speaker, Kerry Schwartz, who's the director of Arizona Project WET. Kerry has worked closely with us for this last few years to train teachers in systems thinking. ThinkWater partners with Kerry's project to enhance existing water curricula with systems thinking and to assess the efficacy of a train-the-trainer model that allows us to reach exponentially more students. So without delay, Kerry Schwartz. Show her some love, it's still going.
Thanks, Laura. I am honored to be here today, and I'm thrilled to be able to tell you about our Arizona story. I met the Cabreras and the ThinkWater team in Madison, Wisconsin in 2014, and I left excited to partner with them in their intention to merge systems thinking with water education. The Project WET Foundation is the premier provider of water education resources in the world. And I'm honored to be the Arizona representative and the recent board appointee. But it's Arizona Project WET's unique position at the University of Arizona that sets us apart. We're part of the Water Resources Research Center, and as such, we stay abreast of all things water. And we're part of Arizona Cooperative Extension, where we use best instructional practices. And we combine the two to create extension programs for targeted audience. Our mission is water stewardship and STEM literacy. And we do that through 3 pathways: professional development that evolves instructional practices and deepens content knowledge, direct student outreach that extends and delivers classroom learning, and community engagement. We've reached 9,500 teachers in professional development and over 750,000 students with water education. STEM education for us is an interdisciplinary approach that integrates subjects into real-world, rigorous, and relevant learning. And we've been doing that for a long time. Yet 2 years ago, when we began a relationship with ThinkWater, and then we took the Cabrera's Systems Thinking 101 course, it opened up a whole nother world of learning and teaching. We got clear that the key to STEM education is thinking, systems thinking. As we learned and embedded our learning into our curriculum units and instruction, we were amazed at what we saw. When we distinguished a river, we watched teachers grapple with the question, what is a river not? And if Google says a river is flowing water, then it's not dry. And yet we looked around the Southwest and there we are, all those dry rivers. And what does that mean for a people, right, that is now in a place where those aren't rivers anymore? Right? Simple questions let us very deep, very fast. As we learn, So like the groundwater system, we absolutely love distinguishing the groundwater system. The groundwater system is not a big lake underground. The groundwater system is moving laterally from higher places to lower places. The analogy, it's like a big river underground, and the blue water in the textbooks, right? It caused huge misconceptions that only deeper thinking can unsee. And the question, what is the groundwater system a part of? Well, sooner or later they figure out it's part of the water cycle. And it's the part that's unseen and largely untaught. And yet it is the water supply for so many communities in the world. And what about our connection, the human connection with the water cycle, right? We create dams, makes reservoirs. Reservoirs store water for us, and yet they increase the surface area. So what's the connection between surface area and the sun? Easy, right? But have our water managers put in the equation evaporation as part of the water, right? On the Colorado River at Lake Mead alone, 600,000 acre-feet of water evaporates from storage every year. So we've got to teach our students to put all the pieces of the puzzle together. In our teacher workshops, we make thinking tangible with manipulatives. We use online training videos, and we use meta mapping. And our teachers in the first year demonstrated a 36% improvement in their own thinking skills, a 67% gain in their ability to use DSRP to help students instruct their thinking, and a 39% improvement in their ability to coach students to become better thinkers. Here's Steve Wahlgren, a master teacher of ours.
Specifically, the systems thinking has been really crucial to get them thinking about parts of a system and how the parts all work together, and then how that system is maybe part of the bigger system, and touching on and tying that back to all part of the system of the water cycle. And so we really kind of dug into pretty deeply systems thinking. We've talked about some relationships between things. Well, how does this affect this, and how does taking out of the if we have to take out of the potable water system, then how does that affect other things? Or if we store too much water, then how does that affect other systems as well? So kind of the interconnectedness of everything has been really great.
The APW team has also reached new levels of improvement. Using the Cabrera's Map Activate Check system, we redesigned our field day that's a cornerstone of our riparian area unit. First thing we did is got clear on what we wanted them to know, exactly what we wanted them to know. And then working with the Cabreras, we realized that we needed to take the perspective of the students if we were going to activate that field day. They're out of school, they're excited to be with their friends, and we knew that we needed to capitalize on that. Habitat Hunters now has students working collaboratively to map the parts of habitat that they observe as they tour the site. They talk, they get excited about what they see, and they're immersed in the riparian area. Secondly, the science investigations part of the field day. We give students science badges. They're botanists or hydrologists, or they're aquatic biologists. And on the back of that badge are science practices. And as they do their investigation, we have group leaders that have star stickers, and we can actually give them stickers for their science practices as they're doing their field study, as they're doing their investigation. So we're awarding, we're checking, and we're continuing to teach the science practices, emphasize those science practices. And lastly, finally, our riparian area, each student has a part of the puzzle, and they put each of those investigations together to answer the question, is this a healthy habitat? So we liked our field day before, but we really love it now. Here's Steve digging into the riparian unit with his students in the classroom. He uses think blocks to activate thinking, the minds, the eyes, and the hands. Taking different perspectives stimulates deeper thinking. And always now, we ask how topics relate directly to the students themselves. Thinking is messy, and it's organized, and it's the job of our students. By addressing systems thinking in our instruction, our students' understanding of water increased. We saw an 81% increase in understanding where their water comes from, and a 69% of our graduates could name a specific river. We see that 3/4 of our students knew how to save water through their behaviors already, but 64% had a knowledge gain on how to save water using technology. On science practice skills, there was a 29% increase in our students' ability to accurately record data, and a 27% increase in their ability to think creatively about their own questions. Student knowledge also increased on another dimension. Working with the Think Water team, our teachers engaged their students in a retrospective pre-post questionnaire, and we saw significant gains in their systems thinking skills, skills that are transferable and scalable across lessons, grade levels, and life. Here's what we learned. Think about your own thinking. Take the time to do it. Think from multiple perspectives. Activate thinking with the mind, the eyes, and the hands. And equipped with a framework and process for thinking, we can solve our most complex wicked problems. Thanks very much.